I think we come to the point where we need to do some kind of a knowledge check. So, Patrick, are you ready?
I'm ready.
Yep. So the question here is the AWS, I'm sorry, the AWS well architecture framework is designed to help you. So there are options. Which one do you opt for as we discussed till now? Okay.
Knowledge check. The AWS Well Architect framework is designed to help. I will go with.
Mhm.
I have two answers here, but I will take C for the moment. I believe.
You can choose multiple answers.
But and then I believe because they say stop guessing your capacity.
Yeah,
Um, uh, e, um, yes, I'll stop guessing your capacity will be the first answer.
okay, the first answer. Do you have any more answers for the same question? Because the multiple answers you can take it here.
Okay, when they say test system at production scale,
Mhm. Yeah,
that is also true because like scalability, they
right.
said you talk about scalability. So, but they increase the amount of administration is not required. That is true because most of the thing is managed by AWS.
Right. Okay. Yeah. So for this question, we can go with stop guessing your capacity needs that we have discussed quite many
Yeah.
times, and test the systems at production scale. That also we have discussed because in the production scale we can have the lower environment with the same capacity, so that you can put your application there and test it. And coming to the third one, lower the risk of architecture change. I believe this also we have done it. So
Yeah.
my answers would be ABC. Let's see what is answers for it.
Yes, it's
Okay.
A,
Yeah,
B, and C.
right. So A, B, and C is the answer. So I think we are on track, Patrick.
Okay.
Okay. Okay, coming to the next question here, the AWS Well Architecture Framework is based on which of the following five pillars? So, can you guess the five pillars that we talked about?
This one I will go with A.
Okay, scalability, reliability, performance efficiency, cost optimization, and operational excellence.
Yeah.
Yes, your answer is correct. Yes, that's the five pillars
Yeah.
that we discussed so far. Yep,
Yeah.
great, great. I think how you're finding the I just wanted to check how you're finding the explanation of the services and the examples that I'm putting in. So are you finding it useful and reliable in terms of the services which we talked so far?
Um, it's it's very useful. Very useful. Um,
Okay.
yes, and yeah, I'm at the moment. I'm very fine with your explanations.
Okay, thanks, Patrick, because this is the first session for both of us, first day of the session. So I just wanted to understand, are we on the same page? Or do I need to give more examples, or do I need to slow down my explanation, or so? Just wanted to have a check with you so we can go with the next session on the same
I
planning.
actually like the reason why I was able to return the the five pillars of the AWS that you mentioned was because when you go to each, like when you were talking about security, it comes on
Hmm.
the top. And then when you went back to reliability, it still came on the slides before you put the notes on. So it keeps on like reminding me. I was able to see it several times now. I like the way that the slides was built.
Oh, that's great. That's great. I think it's helping you much. So
Yeah,
we are happy about it. Yep. Okay. Thanks, Patrick.
you're welcome.
Okay. We'll go to the next section here, which is planning and designing. So we'll try to understand what are the principles involved in planning and also designing cloud infrastructure, which is, the preliminary stage. You can see how do we design your like of the planning and the designing of your cloud infrastructure. Here you need to have the basic understanding of the traditional infrastructure, how it works, so that you can compare it with the traditional infrastructure with the cloud infrastructure, what we are learning in this particular slides. Okay, yeah, so here coming to the planning and designing, here we'll be learning about scaling, how the scaling works, and loose coupling and the redundancy and the cost optimization, automation, and security. So these are the key areas when you do the planning and designing. So we'll go and talk about each and every slide and with examples, so that it will be much adding a value to the particular topic. Yeah, about scalability first, and we'll understand what is a scalability. And even the scalability is one of the feature in the cloud computing that we discussed in the starting of this session, right? So like, and when it comes to the AWS, like on-demand capacity, which is we doesn't know like when the particular system will require more resources, and when the particular system can save the resources and the cost when there is no much need of those services. That's where the scalability, auto scalability will comes into picture. And there are two ways where you can do the scalability. One is a vertical scalability and the next one is horizontal scalability. And we'll talk about what is a vertical scalability and what is a horizontal scalability in the next slide. Okay, coming here to talk about vertical scalability, what it means, increasing the specifications of individual resources. It means, as I told you earlier, the vertical scalability, you will have the memory CPU and you would be replicating the similar thing one more time, which is your vertical scalability, right? So let's say if you're paying $100 for this particular server, and you would be paying one more $100 for this server, which is like almost you're paying the double for vertical scaling, right? And we'll try to understand what is a horizontal scaling. In the horizontal scaling, what we do, we don't replicate the server. Instead, we'll add new resources to it, which means you'll have the web servers in a similar fashion. And instead of adding one more web server like this and CPU, like memory and CPU, what you do, you add resources to it, which means you would be adding some load balancers to it, and you would be adding a couple of additional web servers to take care of the additional traffic which is coming and taking hitting that server. Okay, in this case, you would be okay, we'll see the comparison of these two things at the later stage, but you're clear with both the horizontal and the vertical scaling, right? We'll go to the next session to see. I mean, okay, one second. I'm just going through the previous slides. Okay, probably the main difference between the vertical scaling and the horizontal scaling, when we are, as we discussed, if you are paying $100 for it, if you are doing the vertical scaling with the same memory and CPU, you would be paying additional $100, which is almost doubling the existing uh, cost that you're paying to the services, which is one of the drawback, or which is little expensive what you can see. But when it comes to the horizontal scaling, you would be paying for the similar web services, but you would be paying some little more, for the additional services which you are going to add it here, like load balancing or the kind of web servers that you're going to add it here. You would be paying little more, which is if you're paying $100 here, you would be paying $20 more to it, which is maybe 110 or 120, for example. So horizontal scaling is always, the cost effective compared to the vertical scaling. But this kind of horizontal scaling can't be done in every kind of distributed workload that we have in the cloud. Those things we'll discuss further in detail. Okay.
Mhm. Can I ask you a question?
Yes,
If
yes, Patrick.
horizontal scaling is less costly,
Mm-hmm.
what will be the reason for a company to get a vertical? I'm just asking, what would be an advantage of a company to get a vertical
Like vertical
scaling?
scaling, right?
Yeah.
Yeah, vertical scaling. That's what. So in couple of businesses, you'll not have option for horizontal scaling. You'll not, because all your particular servers or the resources which have been already been ended up with at high capacity, which is supposed to be. So that case, they cannot even do the horizontal scaling, right? So they have to rely on the vertical scaling only.
Okay. Thank you.
Yep. And coming to the stateless application, so what a stateless application talks about here is, need to know knowledge of previous interactions and stores no session information. So if you're talking about the normal applications, like your web applications where you are interacting with a web server or a human here, you would be taking like uh, Patrick, if you don't mind, can you go unmute? If you have
Yeah, let
questions,
me
you can unmute.
yeah, let me mute. No, I don't have
No,
emergency, but the kid.
no problem. Thank you. I'm getting a little distracted. Thanks
Please,
for
please
yeah.
let me just tell them not to come up here. To
Sure.
stay downstairs there. Let me yeah.
Okay. Thanks. Thanks, Patrick. Yeah. Okay. We'll continue with the stateless applications. So the stateless application, like which doesn't have any kind of a session mechanism which can be stored from interacting with stores. There is no kind of a session information which is required where you will go for the stateless application. Example, like the web server that provides the same web page to any end user. For example, if you click on any static web pages, like, or if you are loading some particular website, for example facebook.com or like amazon.com, so it will be giving the static information to you at the starting, right? So it doesn't give you any kind of a stateful information. But when you're doing any kind of it transactions, whereas you're doing some payments using your credit card, right, there you have to have the stateful information where that particular server will take the information of that user using the the credit card information, and do that authentication and say that what are the card information that you have provided is correct. While returning it back, it has to give the accurate information back to the user. There you require stateful information. But whereas when you wanted to access something which is static pages, which is same for every user who is accessing that particular site, you don't require to maintain the state. Okay, that's a stateless application. And coming to the push model. So in the load balancer, we were talking about load balancer, right? If there is a load which is required for the applications, and they would be loading. I mean, they would be adding the additional servers automatically. That elastic load balancer will take care of based on the load which is coming to the server. It takes care of adding the new resources to it. It works on the push model. Let's say if you have 100 hits coming. For example, if one resource is capable of taking 100 loads, one server takes the load, and if additional 100 loads or requests coming to the load balancer, and load balancer knows that additional requests are coming which needs to be taken care for the transaction, and it'll add one more resources to it automatically, and additional 100 requests will go to the another server instead of the server one. Additionally, I mean, it all depends, right? So if you have further more requests which are coming from the request, which should be managed as a stateful request, an additional server will be added to it. It always depends. This is where the cost, everything, I mean, the AWS features come into picture. You don't need to pay for the additional servers every time, only during when there is a more load, where you require more servers to manage those requests which are coming from the customer or in the application. That kind of a load balancer will take care of adding additional resources to here. And coming to the pull model, there is one more mechanism which will be used, pull model, in a queue based. Let's say if we have different tasks which needs to be performed and which are there in a queue based, which doesn't require the response at the same time, and they can wait in a queue based, and multiple computers resources can pull and process the message in a distributed fashion. Which means, let's say I have one task which is being hitted the server, right? And the task 1, task 2, task 3, we have 3 tasks separately. You no need to wait for task 1 to start your task 2. What it does, you will have the multiple resources. The task 1 will be handled by the resource 1, and your task 2 will be done by the resource 2, and your task 3 similarly with the resource 3, and it all provides the results at the same time. It's like multiple requests can be taken care in a distributed fashion. So uh, it distributes all your requests in a different resources, instead of waiting for that particular resources to be available for the another task. So it distributes that work or the task or the request which are coming from the source, and executes and provide your results and put it into your result bucket. That's a pull mechanism. And where it comes to the stateless components, whatever the services that we have in the AWS, right? We have like DynamoDB, MySQL, Amazon S3, and EFS. So the components in the architecture can be made stateless by not storing anything on the local file systems, and instead of storing user or session-based information in a database. So we were discussing about stateless and stateful transactions in the earlier slide, right? So when it comes to, if you don't require to store anything in the local file system when you are working in the AWS. It all stored in the cloud-based applications, including the data which you wanted to store using your DynamoDB or MySQL. Like Amazon S3 and EFS are shared storages, which means you can, if I have given access to you to the Amazon S3, which you can also access from your services, I mean your while connecting to the S3. At the similar time, I can also go and hit the S3 service and get the response from it. It's not uh, you know uh, like a specific database or something. It's a shared storage, you can say, S3. Okay. And coming to the stateful applications, as I mentioned, a couple of transactions which require stateful transactions, whereas you wanted to do some online transaction, for example, right? And where you're using your credit card. When you click on the credit card information and get that authentication, it should be done in a fraction of seconds. We shouldn't be taking 2 minutes or 3 minutes to validate that credit card information authentication and process your transaction. That time your like you will be logged out of the application. So we discussed about Amazon RDS and DynamoDB, which will give you the response within a fraction of seconds, in a milliseconds, as I talked about earlier. So we would be using those DBs in this kind of scenarios instead of going for the traditional DBs.